Hello people! Welcome back to this series on Python programming. Today, we're going to have a look at functions, understand what they are, and how they are useful when writing code. A function in Python is a block of code that performs a specific task. You can think of a function like a tool you create to perform a task that you might need to do multiple times. Functions go a long way in helping developers adhere to a good coding practice. Don't repeat yourself. Functions are executed only when called. Once you write a function, you can call it whenever you need it, making your code cleaner and more reusable. It also helps in the abstraction of the functionality, where you can focus on the high-level logic and not worry about the specifics of the function once it has been created. To define a function, we use the define keyword. Let us look at a simple example. The simplest function has a name and a body. Here we define a function called say hello. As we already know, it does not execute unless it is called. We call the function by using parentheses at the end of the function name. Once we call the function, it gets executed. More complex functions will have parameters and return statements. Parameters are inputs to the function. These are particularly useful when the function is supposed to work with dynamic inputs. We define a new function called say_hello_custom, which takes in parameters. Here is a bit of terminology. In this example, we pass Jake as the value to the function. It is called an argument. An argument is a value passed to a function when it is called, while a parameter is a variable, defined in the function, that receives the argument. In simpler terms, parameters are placeholders in the function definition, and arguments are the actual values you provide when calling the function. A function can also return something, as demonstrated by the function add. It takes two numbers as inputs, and returns the sum of the two numbers. A Python function can have two types of arguments. They are positional arguments and keyword arguments. Positional arguments are the most common type of arguments. When calling a function, the arguments are passed to the parameters in the order they are defined in the function. The order matters here. In the case of keyword arguments, the order does not matter. The values are picked up using the names of the parameters. A Python function can have both positional and keyword arguments, provided that the keyword arguments always come after the positional arguments. To demonstrate this, we define a function called full_name, which concatenates the first and last names, and prints a greeting. In the case of positional arguments, the first name must be given before the last name. For the person named Jake Peralta, the arguments are correctly given in the first example. But in the second example, we interchange the order, giving Peralta before Jake. This makes the function to print Peralta Jake, which is not ideal. But this confusion is eliminated using keyword arguments, where we specify the name of the parameter along with the argument. Quick recap: first name and last name are the parameters. Jake and Peralta are the arguments. No matter the order, the correct arguments are picked up, because we pair the arguments with their corresponding parameters. It is also possible to specify default value for a parameter. In this example, we calculate the factorial of a number using a function. We iteratively multiply the numbers from n down to 1. Instead of initializing the factorial of n variable, we can set a default value to it and use it in the function. In this case, we have set the default value of the factorial to 1. A function can have both positional and keyword arguments. But it should be noted that the keyword arguments must always come after the positional arguments. In this example, we calculate the area of a triangle, given its base and height. The values can be provided in different ways. the arguments can both be positional arguments. Or, they can both be keyword arguments. Or, a combination of both positional and keyword arguments, provided that the positional argument comes first. However, if the keyword argument precedes the positional argument, it causes a syntax error. We can provide any number of arguments to a Python function. Everything is fine, as long as we know the number of arguments to the function, so that we can name them appropriately. But, what could we do if the number of arguments to the function is unknown? That is where arbitrary arguments come to help. Arbitrary arguments can also be categorized into positional and keyword arbitrary arguments. Positional arbitrary arguments are prefixed with a single asterisk, while the keyword arbitrary arguments are prefixed with double asterisks. Let us jump to an example. In the first example, we have a function that can add any count of numbers. As the count of the numbers is unknown, we can use arbitrary positional arguments. We can give any number of arguments, but all those would be taken in as a tuple, because, in the function, we have prefixed the parameter, numbers, with an asterisk. We can calculate the sum and print it. In the next example, we give different attributes of a superhero as keyword arguments. They are taken in as a dictionary, because we have prefixed the parameter, details, with double asterisks. So, it is now a keyword arbitrary argument. We can treat it as a dictionary, and perform any dictionary operation on it. We can use a combination of positional and keyword arguments in this case too, but as always, positional arguments must precede keyword arguments. Lambda functions are short and anonymous functions that can be used for simple tasks. They do not have a name, and they have all the other properties of a function. While the normal functions can have any number of statements, the lambda functions do not have that luxury. However, for the same operation, lambda functions are faster than normal functions. If you want to achieve something simple, and do not want to bother yourself with its naming, you can use lambda functions. Here is an example of identifying the largest element in a tuple, using a lambda function. Recursion is a looping phenomenon, wherein a function calls itself. This is helpful when the problem can be broken down into a smaller subproblems, like tree traversals, Fibonacci numbers, and factorials. As we have already seen an example of factorials, let us achieve the same thing using recursion. We take a number, and multiply it with its preceding number. We continue this till we reach 1. The most crucial thing to note is that the base cases must be handled carefully, or the recursion would go on forever. So, if the number reaches 1, we break the recursion by returning a value of 1. If not, we call the same function for the preceding number. In this case, we calculate the factorial of 5. In the first iteration, the control goes to the else part. It returns the product of 5 and the factorial of 4. The factorial of 4 can be obtained by multiplying 4 with the factorial of 3. This goes on recursively till the number reaches 1. Once the base case is reached, the function returns the value. It is a best practice to always document what the function does by using docstrings. Docstrings are nothing but multi-line comments, which are used inside functions or classes. This is the end of the session on functions, their purpose, and advantages. We also learnt about recursion. For more interesting tutorials, like, share, and subscribe. Don't forget to hit that bell icon. Until next time, happy learning!